So 3D printing in education is a big topic. So I actually have a couple 3D printing in education talks. So I'm going to deliver both of them. But it's awful hard to go up against the derby races. So the very first talk that I have is called Zero Things. So it's a Pechakucha Ignite style. So here we go. Hi, my name is Josh Ajima, and welcome to Zero Things to talk about diversity, opportunity, and 3D printing. My name isn't as important as my online. I go by Design, Make, Teach. The reason why that's important, because if you're sitting there with your phone and trying to fact check this talk while we're going, if you see something by Design, Make, Teach, it does not invalidate any of the points that I'm making. So 3 things about me to kind of give you some context. I'm a K-12 educator. I love 3D printing. Of course, I'm presenting at EARTH. And I'm Hapa. I'm half Japanese and half Caucasian. This is one of my first 3D printed pieces of artwork here. So I'm in my high school and I'm walking by the media center. There's a display cabinet out front. It's a themed display cabinet. They change it every couple of weeks. One week I'm walking by and it's Martin Luther King Day is coming up. And so the display is a little sparse. And I'm looking at that and I'm thinking, boy, I should 3D print something to go into that display cabinet. So I went onto a little site called Thingiverse, and I did a search for Martin Luther King, and I found 0 things. I searched for MLK Jr., and I found 0 things, okay? But I'm a maker, not a problem. I found a picture of Martin Luther King, put it in a customizer, generated a lithophane, created the STL, uploaded the STL on Thingiverse, and now there was one thing about Martin Luther King on Thingiverse. I went to the Google SketchUp warehouse. There was a model. I took it. I converted it to an STL. Didn't do a lot of work. It took about 5 minutes, uploaded it to Thingiverse, and now there were 2 things about Martin Luther King on Thingiverse. So pretty cool. The next month was Black History Month. So I went to Thingiverse and I searched for Black history, and I found 0 things. I searched for African American history, and I found 0 things. So, that seemed odd to me. So I went to Thingiverse and I searched for a popular culture figure. I searched for Yoda. And I found 269 3D printable things that you could download and put on your printer. 269, 0 things for Black history, 269 things for Yoda. So next month was Women's History Month. So I searched for women's history and I found 0 things. Now, I want to caution you, if you go into these 3D printing repositories and you put in women or female as search terms, you are likely to find a lot of things that are not safe for work. And I am sorry, 3D designers, putting fairy wings on a model does not make it okay. That is still inappropriate stuff that you're putting out there. So, imagine telling a kid, hey, 3D printing is awesome. You should be super excited about 3D printing. Go on Thingiverse, find something, download it, and we'll 3D print it. And for that student to find 0 things that represent their identity, their heritage, their culture, their interests, that student finding 0 things that represent them as a person or a human being. So later on in the year, Hispanic and Latino Heritage and Culture Month, I searched for Hispanic and I found 0 things. I searched for Latina, I found 0 things. I searched for Latino and I found 0 things. So not a problem, I'm a maker educator. Gave our English language learner kids some Sharpies. They did some drawings. We photographed, digitized, vectorized, uploaded the SVGs to Tinkercad, extruded those out, downloaded them, 3D printed them. And so now we have this model, right? So that's out of actually protopasta stainless steel, all shinied up, so it looks cool. And so this student right here writes, I am proud to be Salvadoran, okay? And so I don't know, in my school we have a lot of students from Central America, EL students, and English language learners don't have a lot of opportunities in our schools to say, I'm proud to be whatever I am. They don't have a lot of opportunities to share their culture and their heritage. All right? And so we didn't just do one model, we did lots of different models. Not every design that the students created in the class were something that we could necessarily upload to Thingiverse and have 3D printed, but we were able to get a lot of different models up. And as we were doing this, we found like the issue wasn't that there was actually nothing there. It's just that things weren't curated very well. There weren't keywords. There weren't descriptions. It was hard to find the stuff of kind of educational quality. And so we created a Hispanic Latino heritage and culture collection. Like the kids started curating that and finding things that were applicable, and we put it in. That collection got featured on the front page of Thingiverse. Now this is a big deal. This is the only collection that we know of that was curated by someone other than a Thingiverse employee that's ever been on the front page. And I don't know if you've ever been to Thingiverse, but they fired Eric Mortensen, Glitch Pudding, who was an editor for Thingiverse, and the quality and the diversity of the content has gone downhill since MakerBot decided they didn't need that position. But so here's how important visibility is. This is how important being featured is. So this is my model. This won Formlabs 3D Design Awards for top educational model. You can see when I first publish it, right? Nobody's seeing it. 0 views. It gets featured on the front page of Thingiverse. Boom! 5,000 people a day are seeing this model, right? It goes from being, you see that peak drop down, it goes from being the featured model on Thingiverse to being in a featured collection. And so boom, it drops down to like 1,000 views a day. March 1st rolls around and boom, it drops back down to 0. Why? Because African American History Month was over and they took it off the front page, right? So the people who curate and edit our 3D printing repositories, the people who decide what you see have tremendous power to audience. So, but you know, all of this stuff is cool, but maybe this identity and heritage stuff, it isn't your thing. Maybe your 0 things is the Chesapeake Bay watershed and understanding why water in New York ends up in the Virginia Chesapeake Bay. This was designed, and special education teacher came to me and said, hey, my kids can't read a topo map, can we develop something? And so I spent a long time to develop this model, right? So that was a 0 things. Maybe your 0 things has to do with something with geometry. The Virginia Standards of Learning had this nets of a cube. All right, quick, which one of these folds up into a cube? All right, you got it, right? Because most of us can, in our minds, mentally transform a 2-dimensional object into a 3-dimensional object, right? But some kids have issues with that, difficulty. And so what I did was I created these foldable objects, right? So if you look on the right-hand side, these are 3D printed. Some of them fold up into a cube, some of them don't. Quick, can you guess? All right, boom, done. All right, so maybe your 0 things isn't a thing. Maybe it's things that are keyworded correctly. Teaching your kids digital literacy skills to be able to properly tag things, to be able to research and create descriptions and context to the types of models and projects that are out there. And so this was something I did for the Tuskegee Airmen. The National Air and Space Museum is near my house, and they were having Tuskegee Airmen come. And so when I did a search on Thingiverse, I found 0 things. No problem, went and created something. So I want to share my personal 0 things story, right? It can be hard to maybe conceptualize some of this. My grandfather was Japanese American. He was 2nd generation. He was born in California. And my great-grandparents, who were from Japan, but were unable, because of the laws, to get American citizenship, were interred in May 1942. My grandfather stayed there until April 45, when he was drafted out of the internment camp and served in the Army, and eventually retired as a colonel in the United States Army. He stayed in, all right? And so, like, right after this Executive Order 9066 that required the internment of people of Japanese descent on the West Coast, a Japanese American store owner put up this sign, "I am an American," okay? And so what did I do? I went into Tinkercad, I found a similar font, and I recreated that sign in 3D. So that's the idea of like taking your personal 0 things, because there's nothing about Japanese American internment. All right, and so throughout this process, what have I learned? I've learned that 0 things can become 1 thing, right? And 1 thing can become many things. And so, like, kind of what I wish for you and your students in your classroom is kind of the joy and excitement, the anger and the frustration of finding your 0 things. All right, so I have cards for this. There's an Ultimaker Challenge for the Construct 3D conference. If you want your students and kids to participate in this challenge, you can have teachers do this. If you're going to publish the designs or put them out on social media, use the hashtag 0 things. All right, and they made these awesome business cards. They didn't, my face is on them, but. So I have some of those. Okay, so that's talk 1. I've been going around the country, like at maker fairs and conferences, giving that talk about 0 things. So that's more of a general audience, talking about 3D printing repositories and how students can kind of lean in and create content that's missing, right? So I also have this 3D printing projects that matter presentation, and so there's a 3D printer in a heart, and we all know that it's upside down because of support material, like you wouldn't want to, anyway, so that's kind of an inside joke. Most people don't get that, but I know you do. All right, so when we're thinking about 3D printing in schools and trying to push in, we need to create 3D printing projects that matter, right? So you're out here and you're going to geek out about hardware and hot ends and filament and things like that. But when we're talking to classroom teachers, we want to make sure that whatever we're talking about, it matters to students, it matters to the classroom, and it matters to the world. So what exactly do I mean about that? So Enable the Future's here, and they're going to give a talk, but we know, like, when you can 3D print a prosthetic for someone, that matters to that kid, right? That is a story that we can all kind of understand and emphasize. And so when it can happen in your local school, this is a school that's 2.5 miles from me. I've donated a 3D printer to them. They used the library and Makerspace and all these other resources. That's super, super valid and super engaging. But not everyone has that story, right? Not everyone could be part of this particular Enable project, right? Because, I mean, we're a school district of 85,000 students, and this is just one story. So how do you create that same sense of meaning on a larger scale? How do you scale up that sort of significance? And so here's the Brookwood's 3D Design Problem Bank project, right? And what they do is they're basically setting up a site where people submit problems. And so up here at the top, you can see, like, the kids can actually design solutions, right? Because for the Enable project, most of middle school or high school kids are not going to design a new prosthetic, right? They're not going to contribute to the design solution of that problem. They may do something that's aesthetic, right? That makes that, like a superhero kind of thing, skin on an existing design, but they're not going to be able to create original problem or solutions to these problems. With this problem bank, you can see, they're helping the elderly with grips, they're helping people with disabilities, they're solving problems that are in their school and in their community. And so this is one way of generating lots of problems that can be solved with 3D printing, is by creating a problem bank, having your teachers, community members, senior citizens, people with disability contribute to that and have your kids solve them with 3D printing and engineering design and maker spaces in your school. All right? But when I say things need to matter to the kids, it's okay. It is okay to have the cosplay stuff. It's okay to have the fun stuff as long as you don't violate the weapons rules, right? There's a lot of stuff out here you can't bring into the school because it's weapons, right? But, like this guy, Daryl, the broken nerd, right? He does some awesome stuff. The most engaged students that I've ever seen involved in 3D printing were the anime club in my local high school. I mean, those kids went nuts because they get it, they understand it. And so I think it's okay to do lightsabers. I printed lightsabers for kids, and they've printed like sonic screwdrivers and emblems and, like all sorts of crazy stuff, right? Because it matters to them. And that's great for, after school programs and as things around the outside. But when we're talking about what happens during the school day, when we're pushing in, we need to talk about and engage in a broader way. And so the UN Sustainable Development Goals are a great way to approach schools about how design thinking and makerspaces and 3D printing can be part of what goes on in the school. So the UN Sustainable Development Goals are like top problems that are facing the world right now. You know, poverty, hunger, like poor education, gender inequality, global climate change. All of these things are things that are facing us in the world right now, and we want our kids to be thinking about those and developing solutions for them. So that can seem kind of weird, right? These global problems, how does a 3D printer relate to that? So here's one of my designs in Forbes. They misspelled my name, but in the Outsider Art Festival in New York, and they had this contest, this tower design contest. And they had people from all over the world, like designers and architects and like fancy people submitting these tower designs to this art competition. Like, you know, Fredini put his lunar tower in there, all of these awesome things. This is my design that I did in Tinkercad, right? And printed on my home printer in the middle. And then the one on the right is the design I submitted and was printed by Voodoo Manufacturing, right? And so this was about climate change, okay? We have all of these little cottages on the beach. What happens when those tides start getting higher and higher? And so instead of like pulling my hair out of it, I was like, well, let's engineer a solution. And so, right, this is kind of like a drill tower, water tower with a cottage on top. So let's just ignore the problems that are facing us and build up. And so this ended up winning second place in this fancy competition, just using basic Tinkercad and simple FDM 3D printers to create a solution. And the reason why I did this was for my students, was to show them, like, we can use art, right? We can use design concepts to kind of talk about and address some of those. This is free, the Ultimaker Design Engine project. Like, you can download their files, but this is how I did it. Engaged a world history class, and looking at the UN Sustainable Development Goals is through this design challenge where you kind of throw out different design parameters, you give them one of the UN Sustainable Development Goals, and the students prototype and develop solutions to address some of those issues. All right, here's some more concrete examples. Karine Takara is an educator in California, and this one is about colony collapse disorder, right? There's a real issue with bee population decline, and so she designed and 3D printed a piece of artwork that showed like the 40% decline in bees in California, right? So there's 1, 2, 3, 4, 5 pieces there. 2 of them show bees that are in an unhealthy state. This is Karine's son, Cole, right? He was talking about the Syrian refugee crisis. So he took a Syrian flask, but he added elements that documented the issue that refugees from Syria are facing. There's barbed wire, there's tents, there's rubber boats to show that process, right? So these students are engaging in this process. Here's Emily Takara, the daughter. This is a really 3D printing awesome family. They win all sorts of contests. And these were the Future Engineers contest. And so the daughter's thinking about how 3D printing can be used to create medical instruments and scientific instruments to go on different Mars missions and in space and stuff like that. So obviously, you can go to Thingiverse and find some things that are educationally related, right? You can go to 3D printing repositories. Some of them have contests that are related. But if you dig deeper, there are primary sources for some of these resources that matter in the classroom. So the Smithsonian is starting to slowly push out models. That's a life mask of Lincoln. That's not a death mask, right? The NIH 3D Print Exchange has molecules and tools and body parts that you can go and 3D print. Here's a protein molecule that one of my kids did for a science Olympiad. This was without dissolvable supports. This thing was a pain to print, but we were able to create a 3D model of a protein structure that the kids had designed. NASA has 3D resources, and being able to print things out like a space wrench and say, look, this space wrench is on the International Space Station right now, and the technology we have in the same classroom is the same technology they have on the ISS, can be pretty engaging. Here's some other examples, like the 6 crystal families. Could you imagine using that left-hand document as the only resource you have to understand the 6 crystal families? Special ed students don't understand what that means, but we 3D printed out lab sets, like one set for every 4 students of the 6 crystal families, so the students could actually hold these in their hands. We did it for special ed students, but it benefited every student in the class because suddenly, instead of this weird 2D thing that you have to convert in your head to 3D, we have the real 3D object right in front of them. Right? Fujita scale modeling, same thing, left-hand side. Look at those thumbnails. That's how you teach the Fujita scale. This is an F1, this is an F2, right? We created models in Tinkercad and 3D printed them for every stage, so we had an apples-to-apples comparison of each level of the Fujita scale. Historical marker templates. This is Adrian Bower in 2005, RepRap. Whoop, whoop. Here for RepRap. All right. Okay. So history and culture. We've already talked about some of that. World languages, creating objects and models from different cultures, different places. Tactile writing prompts. You know, like these are English tactile writing prompts. I have a whole lesson plan about this. So, but there's symbolism in literature, and actually being able to print out the symbol and have a student hold that creates a different sort of engagement and memory than just talking in the abstract about what these symbols are and mean. And like I said before, art. So this was about a digital photography class. We made 3D printed lithophanes. Every kid designed something. If you can make a good 3D printed lithophane, that's a good black and white picture, right? Because of the contrast and, okay. Art, more fun stuff. And you can do high-level stuff, too. So this is spinal disc research that one of the engineering students did. This was done on a printer bot. He wanted to print on a rotating axis, right? And he came up with some really weird Arduino way to do that, and I said, just take the y-axis motor, flip it on its side, and we'll just print on the axle. And so he was able to print these spinal discs and test them. And sometimes just student designs, getting them thinking in 3D as part of this process. So this is summer STEM camp. And so here's a quick idea I like to throw out is the 3D Gumball Gallery, right? If you have students design things that can fit inside a 42 millimeter sphere, they'll fit into a gumball container. And this is a great way to print every kid's work fast, put it in something where they're all going to be exhibited. I'll give a shout out to Print It Solid because I probably stole this idea from them like 2 or 3 years ago. Right? And so this is a great way. Here it is at Maker Faire, 4 schools competing head to head, but every student got to print a piece. Every piece got put into this machine, and so that's a great way of scaling things so that they work well in the classroom, right? Here's my idea for a Print It Forward 3D printing fundraiser kit. You have the 3D printer, you print out a lot of doodads, you give it to a school, they use those to sell for fundraisers or to give to donors and things like that, and then when they've earned enough money for their 3D printer, they print another 3D printing fundraising kit and then pass it on. This hasn't worked, but I think it will. I'm gonna find the right school to do that with. And the other thing is, like, the design part is important, right? Design. The 3D printing part is what we're all here about, but it's the sharing part, right? Actually publishing that design, getting the views, getting the likes, seeing what happens to engage other people. Like, that's what the whole Zero Things is about. Not everything is gonna get thousands of views, but the critical thing might be finding the right person who wanted to find that particular model and getting that out. So I think sharing 3D designs is critical to this whole process of making in schools and maker spaces. So that's 3D printing projects that matter. On time here, here's my first 3D printer. This was 2013. This is only 5 years ago. Right? And this is a laser cut kit. The reason why I got this 3D printer is because Brook put it on sale for $500 for teachers, right? And that was less than what a graduate course would cost. And I was getting burnt out and I needed something. And so I went and I bought a 3D printer and I got on Twitter and I got on blogs, started blogging and Facebook, and now I'm YouTubing. And that has led to all sorts of wonderful things, like winning the U.S. Department of Education CTE Makeover Challenge grant, bringing $50,000 into my school. I became a Stanford Fab Learn Fellow. I became a VISTE, Virginia Society for Technology and Education, Innovative Educator of the Year. And it was all because I pulled the trigger, right? Instead of thinking about stuff, I said, I need to actually go and buy the thing and start designing and making and sharing stuff with the world. And so that's me. You can reach me at Design Make Teach on Twitter and all of the other places. So thank you very much.